This is the fastest ARM desktop computer in the world. It's the ARM workstation Microsoft wishes they had. Instead of just 8 or 12 cores like the Snapdragon X Elite, this thing has a whopping 128. Instead of a measly 32 gigs of RAM, this thing has half a terabyte. Plus, it has full-size, full-bandwidth PCI Express slots, upgradable NVMe storage, Nvidia graphics, and built-in dual 25 gig Ethernet. Forget Windows though, this thing even beats out the most expensive Mac Pro you can buy. But the main audience for this thing isn't Windows devs, or Mac users in that case. It's actually automotive devs? At least that's what System76 told me in their press release. I mean, it does have a red racing stripe, and love 'em or hate 'em, software-defined vehicles are all the rage, and most run on ARM chips. For the automotive developer niche, a machine like this makes sense. But before we get too far, like a Threadripper workstation or a Mac Pro, this thing's not cheap. It starts at $3299, and this particular unit is topped off checking in at almost $7,000, which is the same price as the base Mac Pro, mind you. But System76 sent it to me for review. I didn't pay for it, so take everything I say with that in mind. Now, I've featured other Ampere workstations before, like the AdLink Dev build. I showed it gaming with Steam and running Windows. You could even build your own workstation with a motherboard and CPU kit from Newegg, like the ARM NAS I have in my rack. But compared to the AdLink build, this one has 8 memory channels instead of just 6. That means you get even more performance out of the massive CPU. And compared to a custom build, this has all the System76 bells and whistles, from their custom case design to full support and a plug-and-play Linux install. And unlike any existing ARM Mac or Windows on ARM PC, this machine supports high-end workstation graphics cards like Nvidia's RTX 6000 Ada, or even the newest high-end 50 series cards. I'm going to test upgrading graphics later, sponsored by Micro Center. But another cool thing is System76 actually builds all these systems here in the US, in Colorado. And it's good to see they allow fun on the production line. These clips were sent over to me from System76, and I asked if they had any shots of building the Astra. It's just cool to see System76 start supporting ARM. And this machine is similar to the one Linus uses to build the ARM64 Linux kernel. That is the Linux Linus, not the YouTube one. But let's dig right in. And I should note, this world record Cinebench score, it's running live. This machine is quiet enough you can only barely hear it while it's beating a 128-core Threadripper workstation in Windows, on ARM. This isn't System76's first rodeo though, and the quiet design borrows from the other Thelio workstations like the Mira, their Intel version. The enclosure's like the Mac Pro. The entire outer case slides up over the top. Inside, there are multiple cooling zones. There's a duct for the CPU and a separate zone for the motherboard, power supply, and graphics card. It also has a little custom breakout with extra fan plugs for more cooling. Looking closely, I spotted a little Raspberry Pi in there. I asked the engineers about it, and they said this updated power board design came out of the work they did on their launch keyboards, which they also sent one along with this machine. This board does fan control, but it's also connected to this sliding connector up on the top case, so it controls power too. There's a tiny power button and LED you can still use without the top cover installed, which is a nice touch for maintenance. This case design is engineered for high airflow and easy access, but it's still ATX compliant. It's not an over-engineered mess like Alienware, but it looks nice and still provides enough airflow to the critical parts. The top-level features are a 1TB NVMe SSD, 512 gigs of ECC DDR4 RAM, an Nvidia A4000 workstation graphics card, an Ampere UltraMax M12830 CPU, and a dual 25 gig SFP Plus NIC integrated into the motherboard. It also has another gigabit NIC and IPMI built in, so you can manage it remotely just like a server. Everything can be upgraded, of course, and you can price out your own build on their site. Like I said, my config is about $7,000, but you can spend over 20 grand if you max out everything. On my ARM NAS build, I used Noctua's Tower Cooler, but on here they went with the Arctic Freezer, another great and nearly silent option. It's nice to see Ampere getting options like these because up until about a year ago, you just couldn't build an ARM workstation quiet like this. Rounding out the inside, it has an ASRock rack motherboard and a 1000-watt power supply. Cable management is tidy, and as an added bonus, they tied down extra modular power supply cables next to the base intake fan, so upgrades should be pretty easy. There's even an ATX 12VO connection if you want to throw in a 40 or 50 series Nvidia card. The case looks great, and the whole thing is serviceable, but I do have a couple gripes. One feature that was constantly frustrating was the loose slot covers on the back. When I was lifting the system out of the box, I heard some metallic clanking, which is never a great thing to hear on a brand new computer. And when I went to upgrade the GPU, the slot covers would pop out and were annoying to get back in every time. Toolless slot covers are great, but they really need a way to retain them so they don't drop out if you touch anything while you're putting in a new card. It's a shame because I love the little design details like the rocket ship in the slot covers and the planets embedded in the fangirl design. Once you get the slot cover retention bracket tightened back down, there's no danger of them sliding out or anything, but it was frustrating enough that I had to mention it. Another annoyance is the lack of any front panel I/O. Even my Mac Studio has some front panel USB-C ports. It'd be handy to have at least one port up front. There's not even that much USB on the back, come to think of it. I had to plug in a USB hub for testing just to have enough ports for the little dongles I had to plug in. Finally, one feature I actually like about the Mac Pro is the handles. A workstation as big and heavy as this is a little awkward to pick up. I mean, it's not portable, so it's not a huge deal, but if you do need to move it, it can be a little awkward since the front edge is flush to the ground. Hopefully over time some of those things get ironed out because the little things mar the otherwise perfect experience of unboxing a $3,000 plus Linux workstation. On the software side, one of the main reasons people buy these things is for Linux support. There aren't many desktop builds that are built Linux first, but this is one of them. The trouble is, even though ARM's been around in the low-end space for years, high-end desktops are kinda new territory. The only other pre-built I know of is the AdLink Dev workstation that I've tested before. But being so new, that means Pop! OS and System76's new Cosmic environment will have to wait. They don't run on ARM yet, but they said they're working on it. In lieu of that, they're shipping Ubuntu 24.04, which is the same distro I've been using on my other ARM desktops. It's certainly adequate, and you still get full hardware and GPU support with it. And this is totally not what it's for, but you can get Steam installed through Box86 and game on the system, with full GPU acceleration, something ARM struggled with in the past. In fact, Ampere and Nvidia already have a ton of cards working out of the box. AMD cards can be a little finicky, but they should work out of the box too. And I even tested both at the same time, and that worked too. Outside gaming, what about Windows? Well, this thing certainly takes the crown away from Qualcomm in terms of being a more professional developer workstation. Ignoring the price tag, this design is better because it's actually a real PC. You can throw in full PC hardware, upgrade the RAM, upgrade the CPU, install anything you want into the multiple x16 PCI Express slots. You can even throw Windows and game on it, right? Well, technically you could, like I did here, but right now Microsoft isn't supporting these pro use cases on ARM, like graphics card support, and they've struggled to get third parties interested in porting their drivers. I think they should though, but that's besides the point. Gaming and Windows aren't the main priority on this machine. It's purpose-built for automotive development on Linux. At least that's what this press release says. Cars run on ARM, and automotive devs have to emulate those systems. If you do it in the cloud, the costs add up over time. And if you do it on x86 workstations, the emulation is a lot slower than running on ARM natively. But I'm not an automotive dev. That's just what this thing's built for. What I care about most is how the system performs for the things I want to do with it. Web development, content creation, recompiling the Linux kernel, that sort of thing. Long story short, it gaps every other ARM PC by a huge margin. Clocking in at 1.7 teraflops on the top 500 benchmark, this thing's faster than every other system I've tested except the 192-core Ampere 1 server. I have to mention really quick here, when I benchmark a system like this, I'm running dozens of different tests. Someone recently accused me of relying mostly on Geekbench. I mean, I sometimes focus on a few tests instead of the full suite I run when I'm highlighting a certain use case, and that could include Geekbench. But every SBC, every computer I test on this channel, it gets the full gauntlet. And a test like HPL, the one I use for this top 500 benchmark, is useful for more than just getting a result and a number. Besides being a consistent way to compare floating point performance across multiple architectures and generations, the test takes a really long time, uses up all the system memory, and hammers the CPU the whole time it's running. And that was helpful in this case because my early test unit didn't have some BIOS tweaks that made sure the fan curves were running properly, and it would overheat and shut itself down. Luckily that was fixed with an update System76 sent me, but the main reason I mention that is because I have all the results I ran linked below. Running dozens of tests over the course of days, or in this case months, always reveals a surprise or two. But that out of the way, I also ran my Linux compile benchmark because, I have a shirt for it over on redshirtjeff.com. It's not under a minute like the Ampere 1 got blasting all 192 cores, but 94 seconds is still pretty good. It's no wonder Linus uses one of these things to build ARM64 Linux. I also installed Ollama. All the results are listed on GitHub, but bottom line, with this much RAM and 128 cores, if you want to run a massive model, you can. It's just going to get slower as the models get larger. The 13 billion parameter Llama 2 model ran at about 8 tokens per second, and that's pure CPU, no GPU acceleration at all. In terms of productivity, I installed Kdenlive for 4K video editing and Blender for 3D modeling. Kdenlive worked surprisingly well. I cut together a few clips, and besides my lack of familiarity with the application, playback and editing were smooth. I think if you forced me to, I could probably crank out one of my videos on this instead of my Mac. Blender ran well too, and I was surprised by how fast CPU rendering was, clocking in at 1:40 for Classroom and 38 seconds for BMW. I checked if GPU acceleration worked, but apparently there are some issues syncing up CUDA and Blender versions on Ubuntu, so I'm still working on that. But all that to say, this machine is a quiet monster.
Look at this. It's rendering Classroom. You can't even hear it unless you're down here by it. Nice job on the thermals there.
For workstation use, it's the fastest ARM computer money can buy. At least, assuming you don't want this thing on your desk. Compared to a modern Intel or AMD workstation though, some things are lacking. It's still running PCI Express Gen 4 and DDR4. Single core performance isn't great either, especially compared to Zen 5 cores. But this is faster in most multi-core benchmarks than even the fastest Intel Xeon workstation CPUs like the W93595X. Phoronix has a full comparison with a Threadripper workstation, so I'll link to that too. But if you're looking at ARM development, or you care more about efficiency and quiet than raw performance, this'll do fine. Just based on expansion, this beats the pants off a Mac Pro or anything that exists with Snapdragon X Elite. Plus, this has an add-in graphics card. I remember back in the days when I could give my Mac new life with an upgraded GPU. Is that possible on this? Well, yes, and Micro Center helped. This came with this puny A400, a pretty low-end workstation card. It's mostly meant for giving someone 4 display outputs, but not for like gaming or high-end CAD work. Micro Center stocks a huge number of graphics cards from low-end consumer all the way up to high-end workstation. And besides that, they have enterprise networking gear, server gear, even network switches and racks. I've said many times how lucky I am to live 10 minutes away from a Micro Center. They've opened a few new stores lately, and another one is coming to Santa Clara in the Bay Area soon. Anyway, one of the friendly associates helped me grab 2 workstation cards. First, an Nvidia A4000. This card is still just a single slot, but it bumps the VRAM from 4 gigs to 16 and has like 4 to 8 times better specs all the way around. It's a little expensive though. And in that same price class is the AMD Radeon Pro W7700. But like the A4000, this is a workstation card. It's not meant for gaming, but for professional work. It has more reliable memory, runs a little quieter on lower power draw, and fits in more systems. Anyway, I brought both cards back to the studio and tested them out. First, I upgraded to the A4000. Those slot covers were a little annoying here, but the swap was quick enough and I didn't even have to remove the side GPU intake fan since the card was single slot and could fit right over the top. After I booted it up, I compared gravity mark results. Here's it running on the A400 I got with the system. That card got a score a little over 7,000. On the A4000, it has the memory and extra speed to boost that score up to 32,000, over 4 times faster. And since you can run larger language models with more VRAM, I loaded up a few models and tested them on both cards. On the A400, the biggest model I could run was a pretty small 3 billion parameter model. It ran fine, but maxed out the 4 gigs of VRAM. On the A4000, it could answer just as fast, but running way more complex models with 13 billion parameters. 4K video decode works fine too. The A4000 had no problems playing back 4K video on YouTube, using the GPU to offload that work. The CPU can do that too, but it's nice to have the GPU acceleration working. Something else I found that's a little more polished in the Nvidia driver, it uses active state power management even on ARM workstations. To save power, when it's not in use, it'll actually downgrade the link speed to like PCIe Gen 1 by 1. Then when you use it, it ramps it back up to Gen 4 by 16. Pretty cool. But that upgrade was easy. I just went from one Nvidia card to another. I wanted to see if I could swap from one brand to another, so I installed the AMD card next. Since it's 2 slots wide, I had to remove the GPU intake fan bracket, but with that out of the way, I popped in the W7700 and I plugged in power to its PCIe power plug. I booted up the machine, and right away, the AMD card worked too. Though I did notice sometimes there were weird text artifacts, like in the browser tabs and location bar. It didn't occur everywhere, just in a few places, but that is a little driver quirk that I think there's a patch that can fix it. I opened up OBS just to confirm I could use hardware video encoding, and I could see the card listed there. I captured some 1080p footage, and the CPU barely noticed. Then I tried reinstalling Ollama to use it with the AMD card, but I realized Ollama doesn't support Vulkan at all, and AMD doesn't support ROCm on ARM at all, so I switched tracks and installed llama.cpp directly, since it at least supports Vulkan. And using that, I ran a 13 billion parameter model and even encountered some nice hallucinations. LLMs are cool and all, but it's gonna be a long time before I trust them for anything more than like a rubber duck debugging session. Anyway, before we get to gaming, I wanted to see if I could run both cards at the same time. And, well, I had just enough power inside for these two cards. But it booted up and both cards were detected okay, but I had some strange issues with the Nvidia display outputs when I had both installed. So I swapped back to the A4000 and moved on to installing Windows. Wait, Windows on a System76 machine? Isn't that anathema? Well, yeah, but if it can be done, I want to try it. So I grabbed my Windows 11 ARM USB stick, plugged it in, booted off it, and installed Windows. Wait, what's that? No need for a custom image? No need to do registry hacks and bypass TPM? No, this rig has ASRock's TPM module plugged in, and with that, you literally download Windows 11, install it, and you're done.
And there's a lot of dust on there. Let's get some of that off. Whoever designed this little spinner is, pat yourself on the back. Oh, here comes Windows.
And once it was done, I immediately fired up Cinebench. Cinebench 2024 supports ARM now, and I'd been hoping they'd update to support 128 cores at some point. My last test on the AdLink system netted a score of 2400, but that was topping out at 64 cores. Well, since that time, Maxon must have fixed whatever bug was holding this back because it got a casual 5003. And yes, that's almost 3 times faster than Apple's fastest Mac Pro, which is the same price as my maxed out Astra. In fact, this is the first time, at least according to HardwareBot, that any 128 core machine officially benched over 5000. We're going to gloss right over the latest AMD chips that cost more than the price of this whole machine, but it is nice to see the multi-core multiplier being so high. The Ultramax isn't the fastest in all metrics, and rarely in any single metric anymore, but it is consistent, and core-to-core performance is great as long as you load up all 8 memory channels. But one system this thing still obliterates is the Snapdragon X Elite. Like, it's not even a contest. To see how much farther we can take Windows, I installed Photoshop, which is also ARM native. And what do you know, it runs just as smooth on here as it does on my Mac Studio. I wouldn't have any hesitation moving over if I just ran Photoshop and needed to make more clickbait thumbnails. And I realized at this point, it was still plugged in through the A4000 and not the VGA output. And my monitor was still showing output, so was the graphics card driver actually working in Windows all of a sudden? Alas, no. I installed Minecraft, and if it's not obvious to you, that's not running on the GPU. And I know, can it run Crysis? Yes, in fact, but again, it's not pretty. Even monster CPUs just can't render out 3D like a GPU can. I also tried launching Blender, and over I was hitting this brick wall. Since Nvidia doesn't have a driver for Windows on ARM, I can't use OpenGL. And since I can't use OpenGL, I can't run Blender, or DaVinci Resolve, or even old things like Quake 3 Arena. And a lot of Windows software just has no clue what to do with this system. Like, hardware info is just like, yeah, that's too much for me. If only we had hardware drivers for Windows on ARM. Like, literally, this is the fastest ARM workstation for Windows on the entire planet. But if my dreams can't be fulfilled on Windows, can Linux come to the rescue? Yes. You see, Crysis at like 1 FPS just won't do. Here's Crysis remastered on Linux. Smooth as butter. And Doom Eternal with ray tracing, it's only giving me 20 FPS, but might I remind you, this is the A4000, a few years old workstation GPU. It's not even built for gaming. And this machine is running all these games through not 1, but 2 emulation layers. First, Box86 to translate x86 into ARM, and then Proton to translate Linux into Windows. It's kind of embarrassing how poorly these games run on Windows. But it would be so much better if Microsoft could get Nvidia to release GPU drivers for Windows on ARM. Think about the irony here. System76 is a Linux company. They wanted to build the best Linux ARM workstation, and they did. But they accidentally built the best Windows ARM workstation too. Now, to be clear, this is not a gaming rig. Gaming is about the furthest thing from what System76 and Ampere intended. That said, after all my work getting 4K games to run smoothly on a Raspberry Pi, my conclusion was the Pi's RAM and CPU were holding it back. Well, this thing has one of the most powerful ARM CPUs on the planet, at least for games that take advantage of it. And it has half a terabyte of RAM. So games the Pi struggled to launch might run amazing on here. To test that out, System76 actually sent a 4080 Super to test, and I'll be doing that soon. I'll also be testing GPU acceleration with rendering in Blender in Linux, and some other tests I couldn't finish in time for this video. But in general, this thing rocks. Now, I'm not going to put on rose-colored glasses. This being the first ARM workstation from System76, there's still ironing out some bugs I ran into. And running benchmarks is one thing, but I have spent over 3 months testing this machine. I used it for almost everything I do day to day. I tested Linux and Windows until my brain went numb. And sure, Micro Center covered the cost of the GPUs, and System76 and Ampere sent over this hardware, but this stuff doesn't pay my bills. So going into a new year on this channel, thank you to everyone who supports it on Patreon, GitHub, and YouTube memberships. I wouldn't be able to spend 3 months on these bigger systems like this and document everything in as much detail without your support. But I have to give my final conclusion, lest this video go on forever. This isn't going to be a gaming PC or a daily driver for most people watching this. It's meant for automotive development work. And it can do some other crazy stuff besides that, but like I said, there are speed bumps. And until Microsoft and Nvidia climb on board, Windows on ARM on this thing is just untapped potential. But one thing's for sure, if this is just the first effort in a team-up between System76 and Ampere, I can't wait to see what's next. Until next time, I'm Jeff Geerling.